Did turn this on. Okay. I will explain it to the camera. Okay. So first we have black or chocolate lab. So there's 8 chocolate and 6 black. So that's a total of 14 out of 20 for that first one. And then probably pick a yellow female. There's 2 yellow females, so the probability of that is 2 out of 20. Probably randomly pick a female. There's 8 females out of 20. And then probably randomly pick a male or female. That's 20 out of 20, all of them. So that's equal to 1 or 100%. And then the probability pick a black lab or a female lab. Well, there's 6 black labs and 8 females, but there's 3 that are counted in both categories. They're double counted. So you have to subtract off the overlap because it's getting counted twice. Those 3 black female labs are being counted in the total for the black and getting counted in the total for the female. So you have to subtract off 3. So then you end up with 11 out of 20. Same thing happens with the male or yellow one. There are 12 males and 6 yellow labs, but there's 4 that are getting counted in both categories. That little triangle, the red triangle, they're getting counted in both the male total and the yellow total. So they're getting double counted. You have to subtract off one of them, 4 of them, because they're getting counted twice when they should only be counted once. So that ends up being 14 out of 20. Given is when you know it's a black lab, means you know it's a black lab. So you can ignore the rest of them and just focus on those 6. And that's the only time that you can, it's not out of all of them, it's only out of a subset, a smaller group. So you know it has to be just out of those 6. So the probability that's male is 3 out of 6. Same thing here. Given it's chocolate, means you know it has to be one of those chocolate labs on the side. So the probability it's male is 5 out of 8. And there's the answer for the last one. Okay, so let's go ahead and take a look at the ones that you guys are trying. What's the probability to pick a male or a black one? So male or black, so there are 12 males, 6 black, but there's 3 that are getting double counted. They're getting counted in the 12 for the male and in the 6 for the black, so they're getting counted twice. So that would be 12 plus 6 minus 3 out of 20, 15 out of 20. The probability that it's female, given you pick a yellow one. So you know it's a yellow lab. What's the probability it's female?
2 out of 6.
2 out of 6. Everybody on board with that one?
Yes, ma'am.
And then the last one?
3 out of 8.
Okay. Given female means it's got to be one of these. Probably it's chocolate, 3 out of 8. Good? Okay. Experimental or observational probability. Let's just put away my lists. Austin, go ahead.
What if we don't know the exact probability of something? The probability of an event is estimated by the frequency of the event divided by the total frequency. Remember, histograms and relative frequency.
Right, do you guys remember that? You take the frequency of that group divided by the total frequency, the percent that's in that class. This is the same sort of thing. So here, we've sampled a bunch of people. We sampled, how many people did we sample? I would take a look at it. How many people did we sample? 50. We sampled 50. How many of them are in the category of O? 21. So the relative frequency of O would be 21 over 50. That's the probability. That's the probability of picking someone in that class and having them be an O blood type. Because 21 out of 50 of them are O blood. That's our best guess for the whole population. That's our sample. Is our sample accurate? Is our population definitely that much? Are all students of Las Positas, is there a 42% chance that all of them have O-type blood? No, it's a sample, right? So anytime you take a sample, it may not match the exact population exactly. You have to kind of remember that. Right? If you flip a coin 10 times, you might get 4 out of 10 heads. Does that mean that probability of flipping heads is 4 out of 10? No, there's randomness in a sample. It varies a little bit. So that always happens, right? That's the whole sample error, which is unavoidable. Some quick rules of probabilities. We're going to go the whole time today. My other two classes, like I said, we got out 2 minutes late. So we will probably get out on time, but not early. So we're just going to go through this. Probability rule 1. The probability of any event E is a number, either fraction or decimal, from 0 to 1. In other words, from 0% to 100%. That's denoted by the probability of E, right? Capital P of E is between 0 and 1. In other words, it's greater than or equal to 0, less than or equal to 1. So the bottom line is the probability cannot be negative. You can't have a negative chance of having something happen. And it can't be greater than 1 or 100%. So you can't have more than 100% chance of something happening. The moral of the story is if you end up on your test and you get a probability of 4, that's wrong. Right? You're probably missing 4 out of 20 or something like that. You're missing that out of. Right? Because it can't be 400% chance of something happening. Rule 2. The sum of all the probabilities, of all the probabilities of all the outcomes in the sample space is equal to 1, or 100%. Note you can't have a 50% chance of heads, 25% chance of tails, and no chance of anything else. It all has to add up to 100%. These ones are kind of obvious, so I'm just going to say them quickly. If an event cannot occur, if it's impossible, its probability is 0. If an event is certain, if it's absolutely definitely going to happen, like the probability of a tree, drawing a tree being on your next exam is certain, its probability is 1 or 100%. Bless you. Quiz, lab problem 3 and 4, we're going to skip those. So just put a little X through those ones. We're going to skip those ones. Complementary events. The complement of an event E, denoted by E bar. Mathematicians are not very original. E with a bar over it, E bar, is a set of outcomes in the sample space that are not included in the outcomes of event E. In other words, E bar is everything that's not E. It's also written like this: E complement with a little C in the corner. E with a little C up there. The probability of E happening plus the probability of E not happening is 1. Makes sense, right? Either it happens or it doesn't. If you add the probabilities, you should get 1, or 100%. Also, if you want to find the probability of E, then you can just take 1 minus the probability of its complement, if you happen to know that. Here's an example. In a study, 23% of people had vanilla as their favorite flavor. Say it again. 23% said vanilla was their favorite. If you randomly pick somebody, what's the probability you pick someone and their favorite flavor is not vanilla? 77. How do you find that? 100% minus 23%, right? 1 minus the probability of its complement, 77%. Good? Here's another example. What's the probability someone does not have AB blood? There's 2 ways of finding it. Everyone take 30 seconds to try to find at least one of those ways. to not have AB blood?
48.
Okay, what's one way? Someone give me a way.
48. 2.
Well, how'd you get it?
Adding everything up.
Okay, so you can add them all up. So 22 plus 5 plus 21 out of 50. That's one way. What's the other way? Subtract. 50 out of 50. 1, right? Minus 2 out of 50. 48 out of 50. Right? 1 minus the complement. So you guys see what I'm saying? 48 out of 50. So whenever you want to use 1 as a fraction, just put the same denominator over the top, and then you get 1. It's easier. Here it is, prettier. Which one's easier, do you think?
Subtracting.
Yeah, the subtracting. I think so too. Okay, the last thing we're going to cover, this is important. Mutually exclusive. 2 events are mutually exclusive if it is impossible for them to occur simultaneously. For example, a puppy cannot be a yellow lab and a chocolate lab at the same time. Make sense? Those are mutually exclusive. Chocolate lab, yellow lab are mutually exclusive possibilities. However, a puppy can be a chocolate lab and a male lab at the same time. So those are not mutually exclusive. Since they can occur simultaneously. You can be a chocolate lab that's male. Cannot be a chocolate lab that's yellow. And we saw that earlier, right? What's the probability of picking a puppy that is a black lab or a chocolate lab? You just added them, right? But what's the probability of picking a, was it chocolate or male lab? Probability of picking a chocolate lab, probability of picking a male lab, subtracting the overlap. The puppies that are in both categories, that are male chocolate labs. You have to subtract the overlap. Good? Okay, so that is enough. That's everything you need in order to do the homework that's due next Thursday. Have a good week.